let me consider one more example on checking analytic function and their derivative. Okay, f of z is equals to, I'll consider an example, cos z. So this f of z, I can write it as a w is equals to f of z is equals to u plus iv, which is nothing but this cos z. Okay, so then this u plus iv is equals to this cos z. I can write it as a cos of z is nothing but x plus I y, and then this x plus iy means cos a plus b formula, means cos a cos b minus sin a sin b, that is cos x cos I y minus sin x sin I y. This is equals to, again this cos x I'll keep as it is, cos I theta I can write it as a cos hyperbolic theta. It means cos hyperbolic y minus this sin x as it is, and sin I theta I can write it as a I sin theta, means I sin hyperbolic theta means I sin hyperbolic y. Now if I rearrange the terms, cos x cos hyperbolic y minus I, okay, sin x sin hyperbolic y. So this is imaginary part and this is real part. So this is u plus iv. So it means real part u is equals to, I'll get cos x cos hyperbolic y, v is equals to, this is minus sin x sin hyperbolic y. Okay, now I have to find their partial derivatives, u and v, their partial derivative. So u I am going to differentiate with respect to x partially. So it means cos differentiation is minus sin x, this is cos hyperbolic y, and v differentiation with respect to x partially, that is minus sin x differentiation is cos x, and this is, I have to keep sin hyperbolic y as it is because I am differentiating partially. Now u subscript y means u I am differentiating with respect to y, means cos x I have to keep as it is. Okay, cos hyperbolic differentiation is going to be sin hyperbolic y, and then v subscript y is equals to this minus sin x I have to keep as it is, differentiating with respect to y. So sin hyperbolic will be cos hyperbolic y. So now you check these two by CR equation. Ux is equals to Vy, okay, and Vx is equals to minus Uy. So therefore this here CR equation satisfies, means Ux is equals to Vy and Vx is equals to minus Uy. CR equation satisfies. Therefore f of z is equals to cos z is analytic, is analytic. Okay, so now I have to find its derivative. That is what I have to do. I have to find dw over dz. So dw over dz, so this is how we are going to write it as a f dash of z, which is nothing but ux plus I vx. Okay, so we already know ux value here, okay, and we know vx value here, that we have to substitute here and we have to simplify further. Okay, so here dw over dz is equals to, so ux what we have here minus sin x cos hyperbolic y plus I into vx what we have minus sin minus cos x minus cos x into sine hyperbolic y. Okay, so I will take minus sign outside. So what happens here? Sine x, this term how can I rewrite? Cos I y plus, here it is cos x as it is, I sine hyperbolic y. This again how can I simplify? Minus sine x cos I y plus cos x sine I y. Okay, so this is nothing but sine a cos b cos a sine b formula. So which is nothing but minus, okay, sine of x plus iy. So it means minus sine x plus iy, what I can write? Z. So this is dw over dz. So if I check that, okay, w is equal to what we have? Cos z. If I differentiate this w with respect to z directly, dw over dz, cos differentiation is minus sine z. So this is what we are getting the answer. Okay. Similarly, we'll consider one more example. W is equals to log z. Okay. So W is nothing but f of z is equals to, we can write u plus I v. Okay. So this is nothing but log of z. Here I cannot use Cartesian form because it is difficult for me to separate real part and imaginary part. Okay, so that is what I am going to do. In polar form I am going to write. In polar form we are going to write it as a r e raised to I theta form. Okay, so we know log m into log n formula. Log m into log n, which is nothing but log m plus log n. So like that I can write it as a log r plus log e to the power I theta. Okay, so here this log r as it is, again we know that log m n raised to m is nothing but m log n. Okay, so I can write I theta log e to the power e to the base e. So log e to the base e is nothing but this is going to be what? 1. So therefore log r plus I theta, we are getting two parts. This is real part and this is imaginary part. So u is equals to what we have here, log r, and v is equals to theta. So with respect to r I'll differentiate, I'll get 1 over r. Okay, so with respect to r if I differentiate I'll get 0. With respect to u if I differentiate with respect to theta I'm going to get 0. V if I differentiate with respect to theta I'm getting 1. Then in case of polar form we know the CR equations are r u r is equals to v theta. Okay, and next here r vr is equals to minus u theta. Okay, so this one if I rewrite r u r, okay, is equals to 1. Okay, so this is equals to this. Okay, and this term vr is equals to u theta. So CR equation satisfied. Therefore what we can say, f of z is equals to log z is analytic because it is satisfying the CR equations. Okay, next we need to find its derivative. Okay, I'll just tell you, if I differentiate this log z with respect to z directly, I'm going to get what? 1 over z. So that is what we have to get even after simplifying this one. Okay, so let me check that with the help of CR equations. So dw over dz is equals to f dash of z. In case of polar form, we had e raised to minus I theta into bracket u subscript r plus I into v subscript r from equation 2. I think you remember this. So we will directly substitute that e to the power minus I theta. U subscript r we have got 1 over r plus I into v subscript r we have got 0. Okay, so therefore it is going to be 0 term. So here e to the power minus I theta over r we are getting. If I simplify this, 1 over r e to the power I theta. Okay, so which is nothing but again it is what? Z, because in the polar form. Okay, so therefore derivative of this log z is nothing but 1 over z. This is how we have to check the conditions. Okay, so in the same way we are going to discuss different problems. Okay,